All right, today we're starting our unit 8 on right triangle trigonometry. And so, from my understanding, Math 2 is the first time that students are exposed to sine, cosine, and tangent. It is not covered in 8th grade math, nor is it covered in Math 1. So, this might be new for many of us. All right. Today we're going to make a right triangle trig foldable to learn about sine, cosine, and tangent. This is in lieu of you taking notes or having me giving you a different paper copy. And then we're going to practice writing ratios. So you would have picked up a sheet today or would have gotten a sheet that had practicing writing on it, writing radium. Okay, this is what the foldable looks like. I'm doing the video to help students who were not here know what we did. The students that were here, we took a piece of paper, we folded it in the middle, opened it back up, folded the two sides toward that middle crease line. Then we did two cuts. We did a cut about a third of the way down, and then we did a different cut about 2/3 of the way down on both sides. Third of the way down, about 2/3 of the way down. And we ended up with 6 flaps. All right, across the top I put right triangle trig, we put sine, cosine, and tangent, okay? On the other side, we end up with SOH, S-O-H, CA, C-A-H, and T-O-A, TOA. All right, you're going to hear me talk about the words hypotenuse, opposite, and adjacent. So right now is as good a time as any to know what those mean. Hypotenuse is the longest side of a right triangle. You should already know that. It's always across from the 90-degree right angle. Opposite means across from. Adjacent means beside of. Think about you going to eat with a friend and you're seated at a booth. You have two choices. You and the friend can sit across from each other and different sides of the table. You would be opposite from each other. Or, for some reason, if you both wanted to sit on the same side, then you two would be adjacent to each other. We're going to be using those 3 words to help us describe the different sides of a triangle. All right. In case you were given a blank piece of paper for whatever reason, I was not able to give you either a prepared copy already, or if you were not here and I just provided you with the paper, this is what the inside of the foldable looks like. Again, this is the cuts. This is the outside edge. So we did write on the inside and on the outside. All right. To help us understand, I first told them to draw a triangle. Okay. We put a right angle in it. I chose to use a Greek letter theta. So this stands for a Greek letter. It actually stands for a variable, just like x. As you advance to a lot of trigonometry and to other math classes, we will start to see some Greek letters pop up from time to time, just like theta. Theta can represent an unknown angle. Now, across from the angle is the side that I labeled opposite, OPP for short. The side across from the 90 degree is always your hypotenuse, abbreviated HYP. Those are the only 2 sides that I'm interested in for this first one. Now we wrote the sine ratio of angle theta is opposite side to hypotenuse. We write that out. That is what we say. In mathematicians' shortcut language, this says the same as what that just said. The sine of angle A, or angle theta, means equals, opposite to hypotenuse. All right, again, this is a shortcut way that a mathematician would write that. All right, it basically represents the same thing as what this writing says. When we did the second middle section of our foldable, again, we started with a right triangle. We marked the right angle. I pick an angle. Now notice that you do have 2 angles you could pick. I could pick this one up here, or I could pick this one down here. I'm choosing the bottom one. It's just my choice. From this angle, notice that this bottom side is adjacent to it. I mean that it touches our angle. It helps actually create our angle. The hypotenuse side technically touches also, but it cannot be labeled adjacent and hypotenuse both, so it would be labeled hypotenuse. Whatever is across from the 90-degree angle is always labeled hypotenuse. For cosine, I'm only interested in the adjacent side to the angle and the hypotenuse side of the triangle. The cosine ratio of angle theta is the adjacent side to the hypotenuse. This is mathematician's shortcut way of saying the same thing. That said, cosine of angle theta equals adjacent side to the hypotenuse. All right, the last one is tangent. As I draw the triangle, okay, again, I'm choosing this lower triangle or this lower angle. I'm going to use theta. And I'm going to look across from that to the side, and this side is opposite side. And of course, the bottom that touches my angle, but not the hypotenuse, is my adjacent side. The tangent ratio of angle theta is the opposite side to the adjacent side. In mathematicians' shortcut language, tangent of angle theta equals opposite to adjacent. Now you might be wondering why we wrote these symbols SOH, CAH, TOA. I want you to have a way to remember sine, cosine, and tangent and what separates them. Notice that there's always two parts that's used. Opposite is used with sine. Opposite is again used with tangent. Okay. Hypotenuse is used in sine and cosine. And then adjacent side is mentioned in tangent, and adjacent side is mentioned in cosine. So of our three ratios, sine, cosine, and tangent, you're only using two sides at a time. We're only ever going to use each one twice. All right, I want you to remember that old famous chieftain, So-Ka-Toa. So, S-O-H, that was on the front, Ka, C-A-H, Toa, T-O-A. Now, you can write it S with O over H, C, A over H, and T is O over A. Those are just ways to shortly to remember. S comes from sine, O comes from opposite, and H comes from hypotenuse. In that order. Sine is opposite to hypotenuse. Cosine is C, adjacent is A. H is hypotenuse. Cosine is adjacent to hypotenuse. Tangent, it's O over A. Tangent is opposite over adjacent. I need you to have a memory device to help remember what sine is, cosine is, and tangent is. All right. In my class, I will be letting you use the foldable on quizzes and tests. It's a way to remember, although sometimes I find that students don't need it, but it's nice to have it if you do. All right. Now, you would have picked this sheet up. We're going to start by writing some sine ratios. The first thing you have to do is know what angle. So the first thing I'm seeing down here is sine A degree symbol. So I'm actually looking for sine of A. So if I check my triangle, sine of A is up here. So I must be looking for this angle that's created from this side to this side. Okay, so that's the angle I'm looking for. I'm going to label, or I'm going to look at my triangle from perspective of A. So if I'm like seated here at A and I look out across the triangle, the one that's directly down here is opposite. 5 is opposite from A. And if we remember our mnemonic, so sine opposite to hypotenuse, I do need the opposite side. Now it gave me 12 and it gave me 13. Which one of those is hypotenuse? Across from a 90-degree angle, the longest side is always the hypotenuse. So for sine, in this particular one, I don't need the 12. So sine of angle A would be the ratio. 5 is opposite on top to 13 on the bottom. 5 over 13. All right. Now, I did that one in blue, and I did that one with respect to angle A. Now, it also asked me to do sine of angle B. Sine of angle B. So this time we're sitting down here and we're looking at the angle created at the bottom right of the triangle. Now, I still need opposite to hypotenuse, but opposite from B is not 5. Notice 5 and 13 side touch angle B, so they are not opposite. 12 is opposite from B. So it does depend on what angle you're looking at. So that makes 12 the top of my fraction. My bottom would be 13. All right, so 12 over 13. Let's go to our next picture. Sine of angle A. So I'm looking at sine of angle A. And again, know where you're starting from. I'm starting from angle A. So it's like I'm seated right here, and here's the angle. It's still so, S-O-H, so I need opposite to hypotenuse. Opposite would be 10, so 10 goes on top. Now which one is hypotenuse, 26 or 24? It's 26. It's always across from the 90-degree angle is your hypotenuse. That's 26. Now, I want you to understand that if you can, you must reduce. All right? So if possible, you must reduce a fraction. 2 will go into 10 5 times. Okay? And 2 will go into 26 13 times. The final ratio for sine of A from the new triangle is 5/13. It's actually the same as the first one. Triangle has, it's like this triangle is twice as big as this one, but it still has the same basic ratio when you break it down. All right, now let's do sine of B. So I'm going to, now we're going to look up here at B. So we're looking at this angle right here. So you always got to know which angle you're looking at. So sine of B. What is opposite from B? Notice 26 and 10 touch it, so they're not opposite. Straight across the triangle is 24, so 24 goes on top. And 26 is still the hypotenuse, so 24 over 26. Again, make sure you reduce your fraction. 2 goes into 24 12 times, and 2 goes into 26 13 times. My final ratio is 12 to 13. All right, we'll finish the next one up. Angle A. Sine of angle A, still SOH, opposite to hypotenuse. Opposite would be the side that doesn't touch it, so it would be 12. Now, which side is my hypotenuse? Is it 9 or is it 15? Well, hypotenuse has always got to be the longest side, so it's going to have to be 15. So this side right here would be hypotenuse. It's always across from 90-degree angle, even if they twist the triangle up like they did here. So 12/15. Okay, sine of angle A is 12/15 up. That can be reduced. 3 goes into 12 4 times. 3 goes into 15 5 times. 4/5. Make sure you reduce if possible. Sine of angle B, our last example, sine of angle B. Okay, this time I'm sitting in angle B. It's like you're sitting in a chair looking out over the triangle. What's opposite from B is all the way over there. 9 is opposite. 9 does not touch B. 15 is still my hypotenuse, and this time 3 goes into 9 3 times, and 3 goes into 15 5 times, 3/5. There are more on this side, which is side number 1. There are more on this side. Those are for you to finish. Now, side number 2, I kind of wanted you to do. Number 1 ratio would be sines. Number 2 is cosine. Number 3 is tangent. Number 4 is trig, where they are mixed. So number 4 is more mixed. You have a sine, a cosine, and a tangent all at once. All right, so let's do a couple with cosine. Just want to make sure that you get started. Okay, cosine is CAH, C-A-H, adjacent to hypotenuse. You still got to know what angle you're starting with. So my first one is cosine of A. Here's my angle. Okay. Now, 5 is opposite, but I don't need opposite. So this time, when I do A, I do not need to look at the 5. Now, find your hypotenuse first. Where's the hypotenuse? It's always across from a 90-degree angle, so it's always across. It's always the longest side, so that makes 13 the hypotenuse. Well, 12 technically touches or helps create angle A. It's the side of angle A, so it is adjacent. So 12 is my adjacent, and 13 is my hypotenuse. That cannot be reduced. Okay, now I'll take off my blue writing, because now I'm getting ready to switch, and I'm going to look at a different angle. So now I'm going to look at cosine from angle B's perspective. All right, so cosine of B. Again, straight across the triangle is 12, but that's opposite. Again, I need adjacent and hypotenuse. I do not need 12 for this cosine of B. All right, 13 would have to be the hypotenuse again because it's the longest side and it's across the 90-degree angle. That makes 5 the adjacent side. Notice that 5 actually touches or helps create angle B. So adjacent is 5. 13 is hypotenuse, 5/13. That's all I'm going to do on this. You can go online and check the solutions to see if you were doing them right. Tangent ratios, and I think I did give points for this in class, so you need to make sure that if you're absent and you do not have a grade, that you turn this in. Okay, tangent. Tangent is TOA. TOA means tangent is the opposite to adjacent, or TOA like this. O over A. So I'm going to be looking, I do not need hypotenuse at all. So this time you do not need hypotenuse. So I'm going to ignore hypotenuse in all of these because they're only doing tangent right now. Okay, so I look and find my hypotenuse is 13, I don't need it. I look and find 26, I don't need it. I look and find 15. I don't need it. So I'm always going to find the longest side, which is across from 90, and I'm going to ignore it. All right. From A, opposite goes first. Which one's opposite from A? 5 or 12? 5. 5 is opposite from A. 12 is adjacent. 5 twelfths. Now, switch, switch, switch. All right, see if the yellow shows up. Nope, not too much. I don't know if you can see it, but B. From B, what's opposite from B? Opposite from B would be 12. So this time 12 goes on top. And then 5 touches angle B, so 5 is adjacent. So 12 fifths. I guess I'll rewrite this in red since it didn't show up. Angle B, opposite, and this touches it. So 12 is opposite, so 12 is on top. That's tangent. Okay, remember, you do not need the hypotenuse or tangent. Now we're going to see if we can do one where you have all three, and the perspective is just A, cosine A, sine A, tangent A. So I'm only looking at angle A. All right, so I'm only looking at angle A, so I'm going to look at that angle. Make sure you know the angle first. I'm going to do sine of A first, cosine of A, and then tangent of A. Sine of angle A. Sine of angle A is opposite, so when I do so, I'm going to do opposite over hypotenuse. So opposite from A would be 5. 5 is all the way across the triangle. It does not touch. 5 over, and the hypotenuse is always the longest side across from the 90, so 5/13. Okay. Cosine. Cosine of A is ca. Ca is adjacent to hypotenuse. So 12 turns out to be adjacent to A because it touches or helps create it, and it's not the hypotenuse. So 12 is the adjacent. Hypotenuse is 13, so 12 over 13. And the last one, tangent. Tangent of A. Okay, I'm still looking at A. Tangent is toe ah, opposite to adjacent. Opposite again is straight across to the 5. You do not need 13. You don't need the hypotenuse this time, and adjacent is 12, so 5 to 12. All right, that's a quick review. You are expected to finish all of the homework on practice on writing.